All right, in this video I want to talk about binomial distributions, and we began talking about them in the previous video with our men and their holiday shopping. There are four things which make something binomial. Each observation is a success or failure. So we have two probabilities, and that constitutes the sample space. The man either waited until December 24th or he didn't, 0.7, 0.3, and that was it. There are a fixed number of observations. So in that video I talked about the fact that we asked 5 men, and that's it, period. We asked 5 and we're seeing how many out of 5. All the observations are independent, meaning we are able to multiply to find these probabilities. And number 4, the probability of success is the same for each observation. So just because we've asked 2 men and they've both said, yes, I saved shopping, doesn't mean we're suddenly going to adjust our probabilities. You typically see this written this way, and we talked about this as a combination. This says I had 5 men and I picked however many, and this is the probability raised to that, and Q represents the other probability, the complement, raised, of course, to the leftover amount. So, 5 men, we want 4 out of 5, so 0.7 to the 4th, 0.3 to the 1st. Typically, our work can look like this. We're in a binomial distribution, out of that many, with a probability of that, and we want this many total. Let's look at an example, and I'll show you how we can type this in the calculator very quickly. So, 30% of all people that enter a clothing store will purchase a clothing item. You take a random sample of 10 and note the number who purchased clothing. So the random variable x here is the number that purchased clothing out of 10. And that out of 10 is important because that helps us distinguish that it is a binomial distribution. Because remember, binomial means we had a set number of observations. In this case, 10. We had 10 people. So the probability that x is equal to 4. So this is a binomial problem. We had 10 total. The probability of success was 0.3, and we're wondering about 4. So how you would calculate this very quickly using your calculator. You are going to go to the distribution button, so second vars, and you are going to scroll down until you see a binom PDF, okay? And then the number of total number of observations, probability, and Rx. You can see it is 0.2. So in the next setting, it's going to be a binomial, 10, 0.3, and 7. So again, you could go and pull this out of that distribution menu. The only thing, of course, that would be different, instead of a 4 here, it would be a 7. So this, if you calculate it, comes out to be 0.009. And that seems really small, and let me explain why it is so small. We have 10 people. 30% should buy clothes. We expect 3 out of 10 to have purchased clothes. 7, so if 3 out of 10 should have purchased clothes based on our old data, you wouldn't be surprised if 2 said yes or 4. A little more surprised if it's 1 or 5. By 7 people saying yes, that seems like too many. That's why the probability is so low. Now, the probability that x is less than or equal to 5. So now it's a binomial, 10, 0.3, and I like to actually say here, I say x is less than or equal to 5. Let me show you, first of all, we could find the probability of 0, 1, 2, 3, 4, and 5 and add them together, but we do have a nice other setting we can use on our calculator to figure this out. Okay, so you're still going to go to that same menu, that distribution menu, but this time you're going to look for binom CDF. The C stands for cumulative. Like a cumulative GPA, it adds up from freshman year on. Well, this adds from 0 up. So I did a cumulative distribution, 10 observations, 0.3, and it adds from 0 up to 5. So you can see I get this probability of 0.95. And that should make sense. That's a high probability because from 0 to 5 includes the most probable outcomes. We expected 3. And 2 and 4 wouldn't have been surprising. So, this, like I said, we're including the most probable outcomes. Now, the probability that x is greater than or equal to 3, here's what I'm going to do. I'm going to do a binomial again. 10.3. I'm going to say that x is less than or equal to 2, and I'm going to subtract this from 1. Okay? So that way, I'm using complements. I'm adding up the probability of 0, 1, and 2, and then I'm subtracting that from 1. I get 0.62. And finally, the probability that x is greater than or equal to 1, again, the easiest way to do this is to do just 0. Find the probability of 0 and subtract that from 1. And we get 0.97. All right. To finish this up, I just wanted to talk about these two kind of distributions. I'm going to move these things out of the way. A PDF distribution, meaning the individual probabilities. If I made a histogram, what would the shape look like? Well, we already said the most probable outcome is 3. This is the most probable because it's the expected value. And what's going to happen is it is going to taper from there. And the area of this curve, or the area of all these probabilities, would be 1. So, it would be like a histogram like this, but it would have that shape. Highest value would be at 3, and then it would go down from there. Whereas a CDF, this is cumulative. So at 10, the height will be 1. Because if you say, well, I asked 10 people, what's the probability between 0 and 10? Well, that's everything. So it's going to start here, and it's going to grow most rapidly at 3, and then narrow, or kind of taper off, almost like a logistic curve. Okay? So our probabilities will almost look like a mound around the expected value, but our cumulative will always end up at 1, because the cumulative distribution from 0 to our sample size, 10, will include the entire sample space. So just ending this, the things to catch about binomial, those 4 settings, that it's that we have a success or failure probability. We just have the 2 probabilities to kind of keep track of. Each trial is independent. Probabilities don't change. And that big important one, that we have the set number that we've taken. Also, please notice that work. Okay, this is kind of similar to the normal curve, where we have to show some work here, even though we're doing a lot of things on our calculator, to kind of show we do know the setting and the distribution that we're in. Make sure you know how to find the PDF and CDF. PDF, remember, is just what's the probability of this one specific thing, like what's the probability x is 4 or 7. We use the CDF to add a bunch of probabilities together. Cumulative. It always goes down, like this is saying, what's the probability of 5 or less? What's the probability? This is 2 or less, so then we did 1 minus. And these distributions, a kind of a mound shaped around the expected value for a PDF, and because the CDF is cumulative, it will end up at 1, because of course the probability of 10 or fewer in this case will be the entire sample space.